right? So dA is equal to m into pi. So from this, so we can write, so our, so B is equal to m pi by A. So B is equal to m pi by A. So now our equation becomes, so Ez is equal to, so K1 cos, so m pi by A,
Sir, that on HZ or EZ, sir?
which one? Sorry, HZ. Right. Good. HZ only. There is no EZ here. There is HZ. Right. So now, so m pi by A into X. So then K3 into cos n pi by B into Y. So Z is, so K1 cos m pi by A into X, K3 cos m pi by B into Y. Right? So then we can write expressions for we go for the next one. Next page. Right. So now our HZ is equal to, we can write, so it's K1, K3, K1, K3, so cos m pi by A into X, cos n pi by B into Y. So this K1, K3, you can write a K or C. So HZ is equal to some C into cos n pi by, sorry, m pi by A into X, so cos n pi by B into Y. So where, so C is equal to K1, K3, and you can write here e power j omega t minus gamma z. So this is the equation for HZ. Then what is the next case we need to write? So this all in the our 6 equations, like you have the, so Ex, Ey, Hx, Hy. Already we know Ez is 0. This is for 0 for the, so TE mode, and Hz already we then the Hz. Now you can write, so remaining 4 field components. You need to write, so remaining 4 field components. So you can write Ex, Ex. So what is the Ex now? Ex is equal to, so minus j omega mu by h square. This is dou hz by dou y, and the full form this one, and minus, so gamma square by h square, so dou ez by dou x. So already we know, so Ez is equal to 0 for this one, for TE mode. So we have only this one. This is minus j omega mu by h square. So dou, this term is 0. So dou by dou y of, so here write the Hz is, so C into cos of m pi by A into x. So cos of n pi by B into y. So e power, so by j omega t minus gamma z. So you can write. Okay. So then this is equal to, then Ex is equal to So j omega mu by h square. So only derivative of y, and you can write c into cos m pi by a into x. So this you can write, this is minus, so n pi by b into, so sine, so n pi by b into y, so e power j omega t minus gamma z. So this is the ex component. Okay, so the same way for ey. So ey you can write, so ey is equal to, so this is, so j omega mu by h square, so dou hz by dou x. So see, for ex, ey, hx, hy, so they're in terms of ez and hz only, ez and hz. So simply I am putting hz is 0 because of is a TE mode. But in TM mode, we are taking hz is equal to 0. So here, so I am removing the ez component, directly I am substituting here. So j omega mu by, so h square, so dou by dou x of, so hz is equal to hz, so c cos of m pi by a into x, so cos of n pi by b into y, so e power, so j omega t minus gamma z. Right? So this you can write, so j omega mu by h square, so c into, so partial derivative of x na, so m pi by a into, so minus, so sine m pi by a into x. So then cos n pi by b into y, so e power j omega t minus gamma z. So in the same way, so we can write for the hx and hy also. Hx, so hx is equal to, so minus gamma by h square, so dou hz by dou x. Dou hz by dou x. So what is dou hz by dou x? So already we wrote now here. So this you can write simply. So this is, so minus gamma by h square, so c into m pi by a, so minus, so sine m pi by a into x, so cos n pi by b into y, so you can write e power j omega t minus gamma z. The same way, so hy is equal to minus gamma by h square dou hz by dou y. You can write, so minus gamma by h square, so dou yz by dou x, already you can write here, so c into cos m pi by a into x minus n pi by b into sine, so n pi by b into y e power j omega t minus gamma z. Now these are the 6 field components for TE mode. So TE mode, so we have the EX component, this is the XZ, this is it, EX, so this is EY, HX, HY. And anyhow, EZ is equal to 0. EZ is equal to 0. So these are the field components for TE mode. Field components for TE mode. Is it clear up to this? So now how to derive the expression for the field components for transverse magnetic mode and transverse electric mode. Transverse magnetic and transverse magnetic, the electric. So TEM mode is not existing in the rectangular wave. Also we'll see later. So now already we saw in TM mode, so only, so the minimum mode existing in the TM mode is TM11. So TM11. That means there is no TM10, so no TM. So 01 mode is existing in the TM mode. Why? So if TM01 or TM10, so we have all field components are 0. In the same way, so you can check here. So here only TE00 is not existing. So but we have the TE10 is there. So TE01 also existing here that you can check. So here, so we don't have TE00. So TE00 is not existing. TE00 is not existing. So but we have so TE10 and TE01. Okay. Otherwise, I go for the next page. Explain here. Is it clear up to this point? M3.
Yes, sir.
So go for the next page. So TE modes, existence of TE mode in a rectangular waveguide. So here, so TE00, or TE00 means where m is equal to 0, n is equal to 0. So in this case, so we have Ex, Ey, Hx, and Hy is equal to 0. That means, so TE00 is not exists. So for TE is first one. So second one you can go for, so TE10. TE10 means m is equal to 1, n is equal to 0. So in this case, so Ex, Hy is 0. If you check later, Ex, Hy is 0. See where m is 0, we'll suppose n0, m and n. See here, so we go for the previous case. Here I am taking. So here n0, where n is multiplied. So this second case, now see here, Ex is multiplied with n, Ex multiplied with n, and also Hy multiplied with n. Okay, these two, Ex and Hy. So these two case, so if n is 0, these two is 0, right? So Ex, Hy is 0. Okay. Okay. So this is T10. So m is equal to 1, n is equal to 0. So Ex, Hy is 0. The next one, that is we have Ey and Hx not is equal to 0. The same manner for the T01. So T01, it is m is equal to 0, n is equal to 1. In this case, so this is Ey, Hx is equal to 0, and Ex, Hy is not is equal to 0. So then you can put the 4. So TE11 we can take m is equal to 1, n is equal to 1. So these all are non-zero. So we have Ex, Ey, Hx, and Hy, Hz. These are non-zero. Okay, and that means this is exists. This also exists, and this also exists, and higher mode also exists. higher modes also. Okay. So these are the existing in the other modes. So remaining we continue in the next class. Right.